Lab, into thin air. After a morning storm, you might notice puddles on the sidewalk. Later that afternoon, the puddles are gone. Similarly, water in clouds seemingly vanishes into thin air. What causes water to disappear? Lab, into thin air. For this lab, we will need the following materials: squares of brown paper, labeled A and B, 2 paper plates underneath, a water dropper filled with 10 milliliters or so of room temperature water, a light source, in this case we'll be using the sun, a ruler that measures in metrics, and 2 thermometers. Step 3. Place on each piece of paper on a paper plate labeled A and B. Add 1 drop of room temperature water to each paper towel. Allow the drops to spread out until they seemingly don't expand anymore, measuring each droplet with the ruler. Record the measurements on the data and observation sections in our notes. Then we will place paper towel A in direct sunlight outside and paper towel B in the shade outside. We will measure the drops every minute for 5 minutes and record our observations. Step 4. Add the drops of water. We will allow time for those water droplets to spread as far as they will. And then measure. A measures at 5 centimeters. B measures at 4.5 centimeters. We will now move to outdoors, where we'll place A in the direct sun and B in the shade. We are now outside in the light source. We are coming up on 1 minute when I will measure these spots. At the 1 minute mark, A measures at 6 centimeters. B measures also at 6 centimeters. At the 2 minute mark, A measures at 5 centimeters and B measures at still 6 centimeters. At the 3 minute mark, it's kind of hard to see A, but I think I can measure it at 4 centimeters and B increased to 6.5 centimeters. At the 4 minute mark, it would appear that spot A is virtually dried up and spot B is now at about 6 centimeters. At our final reading, A has dried up and has a final recorded temperature of 30 degrees centigrade. B is still visible at approximately 6.5 centimeters at a final recorded temperature of 26 degrees centigrade.